This is going to be the third lecture on the topic relation, which is from class 11 maths chapter 2, and in this video I am going to give the complete solution of exercise 2.2. So starting with the first question, on the set A 1 to 14, define a relation. That means the relation is made by the pairs xy in which x and y are connected by this equation, where x and y both should be in set A. So x and y are connected by 3x minus y equal to 0. That means 3x is equal to y, or we can write y equal to 3x. X can take the values, any value from this set, 1, 2, 3, 4, 5 up to 14. Then what will be the corresponding values of y? Y is given by 3x. So if x is 1, 3 ones are 3, 1 each, 1 is making pair with 3, then 2 3 is 6. Then if x is 3, 3 3 is 9, 3 4 is 12, 3 5 is 15. But 15 we cannot take, we can take up to 12. 15 is going beyond of the set. According to question, x and y, both the elements must be from the set A. That means the relation is made by the pairs 1, 3, then 2 with 6, 3 with 9, 4 with 12, and 5 with 15. 15 we cannot take because it is going beyond of the set A. So this is the relation. Now the question is to write the domain, range, and also codomain. Domain is made by all the first components of the elements of the relation. Set of all the first components of the relation makes the domain. That means 1 first component, 2, 3 and 4. This makes the domain of the relation. Then range is made by all the second components of the elements of the relation. Second component is 3, 6, 9 and 12. This makes the range. Then what about codomain? Relation, in this case the relation is from set A to A itself, on the set A. That means from set A to A itself. That means relation is from set A to A, and the codomain is always the second set. And in this case first set and second set same. That means second set is again A. That means codomain is the set A itself, 1, 2, 3 up to 14. So this is the complete solution for the question. Second question is, a relation is defined on set N of natural numbers in which the pairs are made by x and y are connected by this equation, and the condition is natural number x should be less than 4. So x natural number less than 4, that means we can take 1, 2, 3 should be less than 4, only 1, 2 and 3. Then the corresponding values of y is given by the equation y equal to x plus 5. So corresponding values of y, you see, if we take x is 1, 1 plus 5 will be 6. 1 is making pair with 6. 2 plus 5 is 7. 3 plus 5 is 8. So the relation is made by the pairs 1 with 6, then 2 7 and 3 8. So this is the relation, and we are asked to find the domain. Domain, we know it is the set of all the first components of the elements of the relation. First components 1, 2 and 3. This makes the domain. Then range, domain, and we are asked to find the range. Range is the set of all the second components of the relation. Second component 6, 7 and 8, which makes the range. In this case you are not asked to find the codomain, but if you want to find the codomain, the relation is from natural number to natural number only, and the codomain, remember, always the second set. And in this case the second set is the set of natural number, which will be the codomain 1, 2, 3 up to infinite. So this is the complete solution for this question number 2. Question number 3. A relation from set A to set B given by this condition, all the pairs, relation is made by all the pairs in which the difference between x and y is odd. X belongs to A, y belongs to B. That means all the ordered pairs in which the difference between the two components must be odd. Difference between two components must be odd, and first element must be from first set, second element must be from the second set. So I can write the relation like this. If I take 1 from the first set, then what are the numbers from second set will make the difference odd? 1 and 4 possible. 1 and 4 difference is 3. Difference may be positive, may be negative. Difference is 3. It should be odd. So it is odd. So it is correct. I can take this pair. Then 1 with 6 also possible because difference is 5, which is odd. Then 1 with 9, difference will be odd. 8, not odd. So I cannot take. Then I'll start with 2 again. 2, 4, difference is 4, 2, not possible, not odd. 2, 6 also not possible. Then 2 with 9 will make the difference odd. 2 and 9 difference is 7, which is odd, so we can take. Then next with 3, 3, 4 possible, difference is odd. 3 with 6 also possible, and 3 with 9 difference is 6, that is not odd, I cannot take. Then with 5, 5, 4 possible. Then 5 with 6 also possible, difference is odd. 5 with 9 difference is 4, so I cannot take. So this is the complete relation according to the question given. And then the question is only to write the relation in roster form. Write the relation in roster form. This way of writing the elements in second bracket, listing the elements in second bracket, this method is called roster form. Roster form. So this is the complete solution for the question. Now if you want to write domain, you can write domain is the set of all the first coordinates, first components. You can write the range. Range is the set of all the second components, and codomain is the second set. In this case, codomain will be the set B. Codomain is set B, which is 4, 6 and 9. See, this way of writing the relation in terms of xy, which is given in the question, in terms of xy, the relation it is called in set builder form, which we have discussed in earlier previous video. Set builder form. Listing the elements in second bracket, this is called a roster form. So this is the complete solution for the question. If you want to write domain, domain is the set of all the first components, range is the set of all the second components, and codomain is the second set B. Question number 4, it is given like this. A diagram is given and a relation from P to Q. The relation you have to write, the relation is given, arrow diagram. This way of representing a relation is called relation by Venn diagram or arrow diagram. It is a Venn diagram only. It is called arrow diagram. This diagram representing a relation. Now this relation we are asked to write in set builder form, you are asked to write in roster form, and write its domain and range. Roster form I will write at first. The relation, you see 5 is related to 3, that means 5 and 3 making one pair. 6 related to 4, 6 and 4 making another pair. Then 7 and 5, 7 related to 5 making another pair. This way of writing a relation in second bracket, listing the elements, separating by comma, this way of writing a relation, it is called in roster form. And then if I write the domain, domain is the set of all the first components of the elements of the relation, first component 5, 6 and 7, which makes the domain. Codomain is the set of all the second components, that means 3, 4 and 5, which makes the, sorry, not codomain, range. Range is the set of all the second components of the elements of the relation, makes the range. Now if I write the codomain, codomain always remember the whole second set. Codomain is the second set. Now the question is to write the relation in set builder form. Set builder form means we will write R made by the pair x and y, in which x is the elements of the first set, y is the elements of the second set. Now we have to find a relation between x and y. Relation between x and y, here you see 5 and 3 difference is 2, 6 and 4 also difference is 2, 7 and 5 difference is 2. That means y is equal to x minus 2. X belongs to first set, y belongs to second set, that we have to mention. So this way of writing the relation is called in set builder form. So this is the complete solution for this question. We have written the domain, we have written the range. So this way of representing with diagram, representing a relation with diagram, it is called arrow diagram or Venn diagram. And writing a relation in terms of xy, making the pair in which x and y are connected by some relation is called set builder form. And this way of representing a set, writing the elements in second bracket, is called roster form. Question number 5, it is given a relation on set A 1, 2, 3, 4, 6. On set A 1, 2, 3, 4, 6, relation is made by the pairs in which both the components in set A and second component is divisible by first component. B is divisible by A. So I can write the relation at first. I'll take 1. If I take 1 possible, because 1 is divisible by 1. Second component is divisible by the first component, is correct. Then 1, 2 also possible, because 2 divisible by 1. 1, 3 also will be possible. 1, 4 also possible. 1, 6 also possible, because all the second components divisible by the first component. Then if I write 2 is divisible by 2. Then if I write 2 and 3, it will not be correct, because 3 is divisible by 2, not possible, it is not correct. So 2, 4 will be possible, and then 2 can make pair with 6 also, because 6 is divisible by 2. Then with 3 will be possible. 3, 4 not possible. 3 with 6 also will be possible, because 6 is divisible by 3. Then 4 possible, 4 divisible by 4. 6 also will be possible, because 6 is divisible by 4. So these are the elements in the relation. Now the question is to write, first point, to write R in roster form. So this is in roster form. So this is the solution for the first part. Then second part, you are asked to find the domain. So domain means the set of all the first components of the relation. First components 1, again 1, we cannot repeat elements in a set. Then 1, then 2, cannot repeat, then 3, 4 and 6. That is domain. Then third part is to find the range, and range is all the set of all the second components of the elements of the relation. Second component is 1, again 2, 3, 4, 6. Then same elements we cannot repeat. That means in this case domain is set A, range is also set A. If you want to write codomain, also it will be set A, because relation is from A to A only. The relation is from A to set A itself. So if you want to write codomain, also it will be set A only. Codomain will be set A itself. So this is the complete solution for this question. The next question number 6. Determine the domain and range of the relation. The relation is given by this, and set of values for x, it is also given here 0 to 5. That means first component is x, second component is x plus 5, and x can take any values from here. That means x can be 0, 1, 2, 3 up to 5. Then what will be the corresponding values? Should be how much? Corresponding value should be x plus 5. So if we take x is 0, then 0 plus 5 is 5. X is 1, then 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. Then 4 plus 5, 9. And 5 plus 5 is 10. So these are the pairs. 0 to 0, 5 first pair, then 1, 6, 2, 7, 3, 8, 4 with 9, and 5 with 10. So this is the complete relation. This is in roster form. This way of writing is called roster form. And then this way, in terms of xy written, it is in set builder form, you remember. And the question is to find the domain and range. Domain is the set of all the first components of the elements of the relation. That means first component 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4 and 5 makes the domain. Range is the set of all the second components of the elements of the relation. That is 5, 6, 7 up to 10. 5, 6, 7, 8, 9, 10. And this is the complete solution for this question. Next, question number 7. The relation is made by x cube in which x is a prime number less than 10. Prime number less than 10, that means 2, 3, 5, 7. These are the prime numbers which are less than 10. And then the corresponding values of y, that means second component must be x cube. So 2 cube, that is 2 is making pair with 8, 3 with 27, 5 cube is 125, 7 cube is 343. That means the relation is made by the pairs 2, 8, 3 with 27, then 5 with 125 and 7 with 343. So this is the relation in roster form. This way of writing the elements in second bracket and listing the elements in second bracket separating by comma, this is called in roster form. This is the complete solution for the question. If you want to find domain, if the question is to find domain also, range also, you can find out. Domain is the set of all the first coordinates 2, 3, 5, 7. Range is the set of all the second components 8, 27, 125, 343. This is the complete solution. Write R in roster form. Domain and range, if it is asked in the question, you can write it. Question number 8. Set A is given, set B is given, and we are asked to find a number of relations. How many relations possible from set A to B? The concept is like this. It is discussed in the previous video. If set A has m elements, another set B has say n elements, then number of relations from set A to B is given by 2 to the power m into n. In this case, set A has how many elements? 3 elements. 1, 2, 3, 3 elements. Set B has how many elements? 2 elements. So, number of relations from A to B possible how much? It will be 2 to the power m into n. 2 to the power m value is 3 into 2 to the power into n value is 2. So, 2 to the power 6. We can find it 2 to the power 6 number of relations, total number of relations from set A to B. The last question from this exercise is question number 9. A relation on set Z of integers, a relation is made by the pairs AB in which AB both are integers and A minus B is an integer. This is the condition. This is the relation between A and B. By this condition only we have to find what are the possible values of A and B. And we are asked to find what is domain. We are asked to write what is range. Now we have a property of integers, difference between any. Here it is minus. That's why I am taking the difference A minus B. This is the relation given. Difference between any two integers is again an integer. That means A can be any integer, B also can be any integer according to this property. That means domain is all the values of possible values of A, which is Z. Range also all the possible values of B, that means which is also Z. Because the difference between any two integer is again an integer. That means A can be any integer, B also can be any integer. So this is the complete solution for this question. So this is the end of this lecture 3, which is on relations, and in this video I have given the complete solution of exercise 2.2 from NCERT textbook, and all the videos you can find in systematic order in the playlist.